Hello everybody and welcome to the Kubernetes 101 live stream. Earlier this year I started an Ansible 101 live stream. It was right at the beginning of when most of the world went into the pandemic lockdown, and that was not a very fun time, but I thought maybe we could have a little fun on YouTube and stream and learn something together. And I was going to start the series right after that, but a lot of things happened between then and now that kind of prevented that. But we're here now, and I'm glad to be with you. One thing that I really loved about that series was seeing all the different people who watched from around the world. And so one thing that we did on every one of these episodes was everybody, if you feel comfortable doing it, said hello and where they're from in live chat. And I love seeing where everybody's from. I already saw maybe 15 or 20 people put that they're from all over the world. So good to see you. Please say hello. Please participate in the live chat. That's one of the reasons I did a live stream instead of pre-recording these episodes. There's two reasons. One is you get to see me make a fool of myself and see the raw, unedited footage for these videos. Typically for a regular video that I post to YouTube, if it's 12 minutes long, that means I spent 12 or 14 hours on it. For these live streams, I spend the same amount of time, but it's all before I make the video instead of after I make the video. So it's great to see everybody here. The live chat is going to be amazing. I have high hopes for this series. I hope that everybody gets a lot out of it. Please consider subscribing. There's a link right below here. If you're watching in the YouTube app or on youtube.com, you can subscribe and hit notifications, and then that way whenever I start another live stream, you can get a notification when it starts. Otherwise, all of these will be recorded. They'll all be available forever, or at least as long as YouTube is up. And you'll be able to watch them afterwards as well. Also, these streams don't come free. As I said, it takes a lot of my time to work on them. It's time that sometimes I also get to spend working on improving open source software using Kubernetes and some of the tools that I work with. So I do try to spend a lot of time improving open source, improving my projects and improving other people's projects. And I'm trying to make that sustainable for myself so that I can do this work more often and more frequently. So if you feel it in your heart and have the ability to, I have links to my Patreon and GitHub sponsors down in the description below. So find those, and if you feel like you could support this, that's great. Otherwise, I also encourage people to support, not only right now, local food pantries and charitable organizations that help the people that do need money and food and clothing at this time, but also other open source developers, because it's so hard to develop open source software and make that sustainable. A lot of people use it, and a lot of people in some ways can abuse that relationship that they have with open source developers, but so few people are willing to donate money, especially, to help make it a sustainable thing. I also have some new tricks up my sleeve this time. I bought a Stream Deck. I mentioned it a few times in my Ansible 101 series, but now the reason why I am not muted right now, I've done 2 live streams in the past few months, and both of them I was muted for the first 2 or 3 minutes. This time I'm not, because I have a Stream Deck and I can see that my mic is unmuted, which is so helpful. So thanks to everybody who's been watching my YouTube videos, I've been able to afford buying one of these little Stream Deck things, and I can switch using it to my screen share, and I can say welcome on the screen as well. The first thing I wanted to mention is that I think for the duration of this series, at least for the next couple weeks, I'm going to be selling my book Ansible for Kubernetes for $4.99. Now this book is not yet finished. I'm still writing it. I have 6 or 7 chapters complete, but my goal, this is part of the reason I'm finally doing this series, my goal is to have this book finished so that you can start once I finish this series, you'll have this reference available. And this focuses on automating Kubernetes with Ansible, but it covers a lot more than that. And a lot of the examples that I'll be giving in this series come out of things that I've done for this book. It doesn't matter if you're using Ansible to automate it, or if you're doing it by hand, or if you're using some other tool. The point of it is that all of our infrastructure these days should be defined in code and automated. So I have that book available. There's a link in the description below if you want to get it. If you buy it today, I'm still writing the book, but you'll get every update free forever. Ask anybody who's bought Ansible for DevOps. I started publishing that in 2014, and I've published 25 updates to it. and each update brings more content, brings fixes. And this is one of the few books in the world where every example in the book is in CI. So every example that's in this book is tested weekly by GitHub Actions, and it makes sure that all of the examples are relevant and working. Most tech books, when you buy them, they end up going out of date within a week, a month, a quarter, something like that. So my goal with these books is to make them relevant forever, basically, or at least until I run out of time. And thanks for somebody, Knock, gave me 200 of something. One of the things with these live streams is I still don't know, like I got the Stream Deck working and I got some buttons on it, but I have no idea how to do all these automated things and stuff. So as the stream series goes on, things might get better, things might not, we'll see. Things might blow up. My laptop is surviving so far. You can see the CPU is rising slowly over time, and OBS sometimes locks things up. So hopefully that doesn't happen this time. All right, so let's dive right in. The first thing I want to answer is, who is this series for? Just like my book, the goal of this is if you've never even touched Kubernetes before, if you just have heard of it before, that's good enough. Even if you haven't heard of it before, the computing world is wide and deep, and Kubernetes, there's a whole ecosystem around it, and we'll talk a little bit about parts of it here and there. But if you've never touched Kubernetes before, it's perfect for you. If you've touched Kubernetes, if you've deployed an application into it, but you don't know a whole lot about it or how the applications work in Kubernetes, it's still for you too. My intention is that somebody who has either used containers and Docker and things like that before, or even if you haven't used any of that before, but you're a developer who deploys applications, or you're an ops or sysadmin person who helps manage applications, if you have very basic Linux knowledge, the knowledge of running applications on a server, then this is for you. I want to bring you up to speed and teach you about Kubernetes and how to use it and where to go for it and all that kind of stuff. So because of that, I want to start way back at the beginning. I want to go back all the way to the days where we had a big single server running somewhere, running our applications. In this case, this server is a server that I helped manage at a radio station in St. Louis. And we had a name for this server. It had a name. It's actually blurred out here just because I don't want to potentially run into any issues with this. But we named our servers back then because they were very important. And you saw that there's a tech support number on that server. These servers were very important to us because we would install things on them and we would need to make sure that server kept running forever and ever, as long as possible, with no hiccups. But that introduced some issues. If the server had power issues, or if it had one of the hard drives fail, we would have to scramble to make sure that we had another hard drive to replace it. And you see there's a tape drive here, so we had to do backups on the server. All these different things made this kind of infrastructure hard to manage. And but this was how it was for a long time. We had mainframes and we had different server setups for a long time. But for most people, you would have one server running somewhere. As time went on, we started to split things up a little bit for better redundancy, for better availability. And this is a picture of a diagram that I used for my Raspberry Pi cluster that ran Drupal called the PyDramble. If you want to find out more about it, go to pydramble.com. This cluster is similar to many people's clusters for web applications, where you have some sort of server running in the front of it, running something that proxies requests or load distributes the requests. I often use Nginx. You could use Varnish. You could use HA proxy. There's lots of different things you can run on this. So you'd have a server up there distributing requests to a bunch of back-end web servers. In my case, these servers ran PHP and Drupal and Nginx. And then there's some sort of storage system. In my case, I used GlusterFS. But you could use Ceph, you could use NFS, you can use lots of different technologies for storage. And then you might have some caching servers, you might have database servers, and in each of these layers, you can have more complexity. So the database might have a primary and replica or a whole cluster of servers. The caching servers, you might have a pool of caching servers. So we started going down this path, and a lot of times we would use cloud computing to do this because we realized it's not very fun to go from managing one big server to managing like 50 servers, especially if you have a small staff. So cloud computing became extremely popular. And this, I would call it like cloud 1.0. This cloud computing was basically taking all of your servers and running them in someone else's computers. So it's basically moving all of the things that you would run locally into a cloud, so Amazon or Azure or Google Cloud or something like that. Or before it was bought out, SoftLayer, which is now IBM. You would move all of your servers into a cloud somewhere. But it was getting hard to manage because as we grew our infrastructure and as we ran, a business might have run 5 or 10 applications in the 90s, and then it became 100 in the 2000s, and now it's 1,000, 2,000 applications. And you have many different teams managing these things. It became very hard, and so we had tools like Ansible and Chef and Puppet and CF Engine, and even some cloud providers like Amazon would provide tools and services that would abstract things away from you. So Amazon has a whole suite of different tools where you can build infrastructure and connect things together without having to have as much sysadmin knowledge. So we got to that point, and that's still where a lot of people are today, and there's nothing wrong with it. One of the things that I still have is I still have a lot of servers that I manage with Ansible or with Terraform or with CloudFormation, and they kind of connect together, and I use a configuration management tool to connect them together, and it works fine, and sometimes you can even save costs doing that. But Kubernetes comes from taking this idea to the extreme, and instead of worrying about those servers and the relationships between the servers and having one server run one thing and one server run another thing, even if they're virtual and it's a cloud running in someone else's infrastructure, it takes all that and abstracts it away into basically a software-defined cluster. So we now have a pool of servers, and you can have different types of servers in that pool, and we might talk a little bit about that a little later in the series. But the idea is you have a pool of servers, and then Kubernetes runs on it, and it manages the applications you want to run on those servers, but Kubernetes does all the hard work for you. Hold on a second. I need to... one of the things that I do not have automated is the scrolling through my notes, so I still have to scroll through here and find where I am. So anyways, Kubernetes will manage things on your servers, and it uses different words to describe different things that you're going to run. The primary thing that we'll be concerned with early on is pods. Pods are things that Kubernetes can run on servers that have one or more containers on them. We'll get to what all that means later. But it distributes things on your servers and makes sure that you're utilizing your servers well. And this can save you some cost too, because if I go back to this slide, if we wanted to scale this up or scale it down, or if we found that we deployed 20 caching servers and we really only needed 3 or 4, then we'd have to repurpose those servers and change our automation and change the way that things work. And it wasn't always great. Or there are some cloud providers, like Amazon has a lot of this auto-scaling built in, but you're locked into Amazon at that point. Or you're locked into Google Cloud if you use their system for scaling up and down. So Kubernetes abstracts all those kind of things away so that we don't have to deal with it. Now, another thing that I want to talk about a little bit to make sure that we know where we're coming from and where we're going is where Kubernetes comes from. And here, I guess this is kind of its origin story. And I saw a couple other people gave super chats. That's awesome. Thank you so much. And even I mentioned earlier, supporting open source is hard. Supporting education resources and things. A lot of people might pay for Pluralsight or other video training courses or things. I try to make these free because I know me coming into software development, I used as many free resources as I could, especially early on when I didn't have the money to pay for these things and I didn't have a job that would give me free trainings and things. So I try to pay that forward as much as I can. So anyways, Kubernetes origins. Kubernetes comes from a system at Google called Borg. And Borg is the system that Google, I believe, still uses today. Last time I checked it was. But Borg is a system that runs their clustering and deploys their applications throughout their infrastructure. And, companies like Google, Facebook, Netflix, Amazon, they have hundreds of thousands, probably millions of servers, and they need ways to distribute applications on them that are efficient and things like that. And bonus points to anybody in the live chat who can correctly identify this character, and his name is not Jean-Luc Picard, or at least technically his name is not at this point in the series. Anyway, so he was a member of the Borg at this point, and Google named their project Borg, I guess, after it because it's a collective of servers and running all these different applications. I see Edwin already has the answer, and Nomadilog, and now a lot of people are putting it. So good job, everybody. Yes, Locutus. So anyway, so they took this Borg, and there's a few engineers who were like, you know what, we want to take this and make it more accessible and more open source, I guess. They wanted to take over a lot of the market of this automation of clustering. And they also realized that certain vendors were having a lot of lock-in through the technologies that were proprietary that they would put out. So they turned this thing into Kubernetes, and at the time they initially started writing it in C++, but they saw that Go, a new programming language, was getting popular and very easy to approach, and a lot of developers who are familiar with things like Python could jump into Go pretty easily. So they rewrote it in Go. They wanted to call it Project 7 after this character, who you can identify this character in the live chat if you want. This particular picture is not from Star Trek Next Generation. It's from the newer series, with Picard. So anyways, this character, they named it after this character as kind of like an ambassador to the humans through the Borg and all this stuff. But the legal department did not think that would fly, and didn't want to have this new cloud technology be encumbered by lawyers suing Google or suing these new engineers. So they decided to change it slightly, but still keep the spirit of that progression of naming. And they called it Kubernetes, and that has a few different tie-ins. First of all, you can see on this image, there are 7 spokes on this helm. And those 7 spokes harken back to Project 7, 7 of 9. And also it's a helm. I think one of the things I enjoyed most about Star Trek The Next Generation in particular, but also some of the other series, is it does have a lot of references back to navigation and shipping and boating and navies and things like that with all the different terminology. So in the Kubernetes ecosystem, you'll see that a lot of different kind of references to nautical terminology. For instance, Helm, a package manager that you might have heard of, was the first big package manager for Kubernetes and is still very popular today. So anyways, so that's Kubernetes history. Another thing you might see a lot, and this, especially for somebody new, you're like, what? Where did this K8S thing come from? Kates. Nobody knows what that is. Well, Kates is actually called a numeronym. And I had never known what a numeronym is until a few years back. I started seeing a different couple ones of these used. One of them that you might also be familiar with is W3C for the World Wide Web Consortium. So World Wide Web is 3 Ws. Some people say W3 instead of www or World Wide Web. Another one that's kind of ironic that you might see is A11Y. That stands for accessibility. The way that these work is you take a word that's longer, like Kubernetes or accessibility, you slice out all the letters between the first and last letter, and you count how many letters there are and slap that number in the middle. So Kubernetes is K and then 8 letters and S, so it's Kates. But anyway, that's how that works. And it's ironic that A11Y is accessibility, because unless you know what that means, somebody will be like, oh, we're going to the A11Y conference. And you're like, what does that mean? And, for people who need accessibility, I've gone through periods in my life where I had poor eyesight and things. Like, you don't want to have hindrances to understanding what something is. So using A11Y instead of accessibility is kind of ironic, I think, for that purpose. But you do see Kates a lot, and we'll see a lot of other acronyms and backronyms and numeronyms and all kinds of stuff in this series. So in 2015, Kubernetes was released. They decided to put Kubernetes into a new organization called the CNCF. That stands for the Cloud Native Computing Foundation. And the idea is that this new foundation would take cloud native technologies, things that are built to work in this new order, where it's something built to be as stateless as possible and be able to run on the cloud without concern for running it on bare hardware as much, things like that. Anyways, what happened is that they started publishing this landscape. You might have seen this before, you might not have. You can find it, I think, if you just search for CNCF landscape, you'll get here. Initially, this was kind of like a way to see tools that worked with Kubernetes natively or worked in cloud native. But nowadays, this chart is like 85% vendor spam, where it's like, we have to jump on this bandwagon. So we have to get our logo somewhere on this chart. So everything that has anything to do with anything remotely related to cloud computing found a way to get their image on this chart. There are a lot of technologies on here that are pretty cool and a lot of companies that are great and stuff. I'm not trying to detract from that, but a lot of people see this chart and they're like, oh my gosh, Kubernetes is way too complicated. I'm never going to understand any of this stuff. And all I have to say here is that there might be like 300 things on here, but we only need to know about 1 or 2% to be productive and happy in Kubernetes land. So I guess another thing that I want to talk about with this is Kubernetes is a little more complicated, I think, than just running an application on a server or even using something like Docker Compose if you're familiar with Docker. So you might or might not want to use Kubernetes for a project, and that's really a decision that's up to you. There are a lot of things, and I'm going to talk about a lot of them, that make Kubernetes more simple and easier to deploy, but Kubernetes does have some overhead. Usually it's best to have at least 2 servers, maybe 3 or 4 or 5 or 6, depending on the amount of availability you want with your Kubernetes cluster. So there is overhead, there is a learning curve, and it's not for everything and everyone. I use Kubernetes a lot, but I also don't use Kubernetes a lot. My main website, jeffgeerling.com, which gets a decent amount of traffic, is still running on a single VPS, and I just have good backups of the VPS. And there's been 1 or 2 times where I've had to restore backups. Make sure you always practice restoring backups. I have a video coming up on my YouTube channel talking about RAID and backups. But that's just 1 server, and it's fine. It's been working for me for 8 or 9 years now that way, and it'll probably keep working that way for a very long time in the future. I don't see that changing. If it works, and it's a little cheaper for me to do that because it's 1 VPS that costs like $10 a month instead of having 3 or 4 servers or having a service that I have to pay for in addition to the servers. So anyway, another thing that I think is important to state here is that there are a lot of service providers for Kubernetes, and this is a good point where I think I could give a shout out to Amazy.io, who has graciously sponsored the series, and they're also part of the reason I was able to buy this fancy little Stream Deck device so that I can do my streaming a lot better. Amazy.io helps you with your Kubernetes so that you don't have to worry about all the complicated stuff in this chart. So that they're going to deal with all these technologies, integrate them together in the right way on any kind of cloud computing infrastructure you need to be on, and help you to be able to just deploy your applications and not have to worry about the Kubernetes stuff underneath it. So thank you very much to Amazy. Go check them out. It's amazy.io. And they have some other products like Lagoon that help with deploying your applications. I found out about them a few years back. Some of the people that founded it and work there are very deeply integrated in the Drupal open source community and the Kubernetes open source community. So they're very, very strong open source company at heart, and I'm usually very happy with anything that they do, so I highly recommend them. All right, so the next thing that we're going to do here is we're going to start getting into actually using Kubernetes. There's a lot of different types of Kubernetes out there, and I have 4 images here. There are a number of different ways that you can do this. You could install Kubernetes. You could set up a Kubernetes cluster using a tool called kubeadmin, kubeadm, from Kubernetes. That's the kind of official way to do it. Kubernetes is a little bit heavyweight, and especially when I'm doing local development or testing, I don't like to install the whole thing because you need at least a pretty beefy server, and it takes up a lot of space on your computer. It takes up a couple gigs of RAM just to run Kubernetes, and that's before you start running your applications on top of it. So there are a lot of different tools out there that help you to run Kubernetes easier, like K3S from Rancher. I actually did a series, and you can't see it right now because this is a live stream and I can't do this magic. But after the live stream's over, I'm going to put a card right above me that shows you some videos that I did with a Raspberry Pi cluster using K3s, because K3s is a lot more lightweight and it works great on ARM processors. And I did that series using K3s. It's a great little distribution, but again, it wants to use a little bit more resources, and it's not really meant for local development on a single computer where you bring up clusters and down clusters really quick. You can use it that way though. Another thing that's really helpful, and I use this quite a bit, I use it for almost all this continuous integration jobs I do, is Kind. And that is Kubernetes in Docker. And you can use this to develop Kubernetes. You can use this to develop your applications and test them. Kind is really cool because it lets you build different types of little clusters running in Docker containers, and you can run it in continuous integration environments like GitHub Actions and Travis and Circle CI, GitLab CI, all these different tools. And you can run it locally on your computer. So I often use this when I want to test my Kubernetes stuff. So I'll be referring to it a few times in this series, but not today. The one that's in the bottom left is called Minikube. And Minikube is one of the most user-friendly ways, at least in my experience, to develop with Kubernetes and test things in Kubernetes, because it offers a lot of things out of the box that you can pop onto it that lets you test things like ingress, which we'll talk about later, and services and exposing things on your computer and browsing applications through your web browser and all that. So we're going to use Minikube in just a minute. There's so many other things too. There's OpenShift if you're running in production and you have a bunch of servers to run. There are other distributions like MicroK8s that's useful sometimes with edge computing, just like K3s, where it's a little lighter weight distribution of Kubernetes. There's also this little thing. It's a little bit hard to see because it blends in with the background. I should have probably put a white border on it or something. But this is one I just found out about a couple days ago called K0s. And I guess that stands for chaos. I don't know, or chaos. But it's another distribution that's meant to be very lightweight, and it's distributed as one single binary, so it's easier to deploy. Early on in Kubernetes history, it was a lot harder to do these things. Nowadays, we're kind of spoiled for choice, and you can find a Kubernetes distribution that matches your needs a little better, and it's easier to run it on smaller hardware. Later in the series, I'm going to be showing you how I can run Kubernetes on some Raspberry Pis. And that's pretty cool because Raspberry Pis are super cheap and you can build a home cluster and do a lot of cool things on it. So anyways, on to the portion where I'm actually going to show you how to build your own little cluster locally with Minikube. So I'm going to get out of there, open up my terminal, and I hope this is big enough. So I'm doing a new thing with the streaming series. I have my screen share. It's very fancy looking, I think. The screen share is over on the right. I can't even see my window here. Hold on. The screen share is right there, and I'm here, and you can see both of us, but please let me know in the live chat if it's hard to see with the size of this text, and we can change it up for the next episode, but I think this should be visible for you. Let's see. Somebody realized I'm using an Apple product. Yes. And it's an interesting transition time in the Apple world with the new ARM processors. But I do use Linux, Mac OS, and I do have a Windows PC, but I mostly use it for Halo 3 and testing things. All right, so what we're going to do next is build a little Kubernetes cluster. And there's going to be some things in here that you might not know what I'm doing. You might not know how it's working, but that's okay. The point of this is just to show you how quick and easy it is to bring up Kubernetes on your computer. And I should note that my computer is currently, it might look like this isn't much CPU, but anytime it gets above 20-25%, things get a lot slower because OBS, for some reason, even though it says 9.5%, it's sucking up a lot of power. And we'll see how this works today. So the first thing that you need to do if you want to use Minikube is to install it. And on my Mac, I use Homebrew, so I can just say brew install Minikube. And I already installed it, so it's just going to say it's already installed. But there's a lot of other ways to install it. The easiest way is just download the binary and then put it in your path, and you can run it. And you can also install it on Windows or Linux, no problem there. The other thing that you're going to need is, now here's something that could be controversial. Raise your hand if you've ever pronounced the term KUBECTL. And there's about 100 different ways to pronounce it. somebody at some point got an official pronunciation snuck into the code base, I think. And the official one is kubecuttle, like as in a cuttlefish. Some people say kubecuttle, some people say kubecuttle, like you're cuddling up with Kubernetes. Other people say kube control, other people say kubectl. Basically, there's 100 different ways to say it. I'm going to usually say kubecuttle, but sometimes I'll say kubectl, sometimes I'll say kube control. Please don't hate on me for different ways that I say it. I'm terrible with people's names also, and you know, if I say one of your names in live chat and I butcher it, I'm not trying to be mean, I'm just the worst person at pronunciations. Anyways, you're going to need this tool. So I'm going to say brew install kubectl. And again, I've already installed it before, so I have it here. And again, you can install this different ways. You can just download the binary and put it in your path. On Windows, I think it's also available through Chocolatey. So however you want to install it, you just need to get Minikube and kubecuttle, kube control, kubectl, whatever. All right, so once you have those, you need to bring up a cluster, and it's as easy as Minikube start. And there are other options you can use. So Minikube by default is going to use 2 CPUs, 6 gigs of memory, and 20 gigs of disk space. It's an expanding disk, so it's not like it's going to suck up 20 gigs right away. But there's different ways for Minikube to build its VM too. So there's a lot of configuration. I usually just use the defaults unless I'm doing something special. Like one time I wanted to run Ansible's AWX in Minikube, and I found out it really needed like 8 to 10 gigs of RAM. So I just increased the memory through a command line option. So that's going to go ahead and build me a Kubernetes cluster. By default, it's going to use the latest version, 119.4. And hopefully my CPU doesn't commit seppuku here. It looks like things are going okay. Okay, so Minikube also configures kubecuttle so that it has the right configuration to connect to this cluster. If you work with lots of different clusters, you'll have to learn a little bit, and I'll talk about this later on. Learn about how kubecuttle gets its configuration to connect to different clusters. But for now, all you have to know is that when you create a Minikube cluster, it configures things for you, and you can start running commands like kubecuttle get nodes. And this is going to show me how many nodes there are in my cluster. There's just one. By default, Minikube's just going to give me one node, and that node is set up as the master node. In Kubernetes, you can have master nodes, and for high availability, you want at least 3 of them for consensus with the database. But if you have a real-world cluster, you'll also have other nodes that are workers and just normal nodes that run your workloads. And typically, in a production cluster, your master node would never run actual applications. In this case, we're doing that just because it's convenient to do it locally. But typically in production, you want to have separate servers that run the actual applications you're going to deploy. So the next step is we want to put something on it. We want to run an application on this cluster. And there are a bazillion different things we could do here. I'm just going to do a simple thing. I'm going to use a deployment and tell Kubernetes to deploy an application, which is just a container image that has an application inside of it, to my cluster. So I'm going to say kubecuttle create deployment. And kubecuttle is pretty simple. You can get things, you can create things, you can delete things. So I'm going to create a deployment, which is basically saying deploy this thing. So I'm going to call it hello Kates. And I'm going to deploy an image, a Docker image, image equals Geerling /cube 101 intro. I'm going to deploy that into the cluster, and it tells me helpfully that my deployment has been created. We're going to get way deeper into what a deployment is and what's happening in the background and all that later. Right now, we're just creating this deployment. So the next step is I'm going to say kubecuttle explodes. I think that might have been Redshirt Jeff there saying explodes. Kubecuttle expose. And this is going to let me see that application from my computer, because right now what Kubernetes does by default is it runs everything inside the cluster with a private software-defined network inside the cluster. So things inside the cluster can see each other, but unless you expose something using something called a service, you won't be able to see that thing from outside of your Kubernetes cluster. So we're going to expose it so we can see it from my computer, my web browser. So I'm going to say expose deployment hello Kates. That's the deployment that I just did. Whoops, I forgot. I also need to say type equals node port, and I'll get to that in just a second. And then the port that I want to be exposed on in the container, this container exposes port 80 because it's basically a website running Apache. And I'm telling it node port. There's a lot of different ways you can expose something in Kubernetes. And we're going to get into a lot of different types and a lot of different ways that you can have web applications be accessible from outside the cluster. Node port is one that's very simple. All it does is it takes a random port, a high number port on all the servers in your cluster, and it assigns it to the service that you're running. So in my case, this hello Kate's. And it says that it's exposed now. I want to get that port, whatever port it assigned, so that I can access my service. So I can say kubectl get services. When you expose, it creates a service. Hello Kate's. And it's going to tell me that this is the internal cluster IP. So inside the cluster, I could reach this service at that IP address and port 80. But outside the cluster, I'm going to need to use this port because that's the node port that's running on all the different servers, in this case, just one server. So I can access it on that server, but I don't know the IP address. There's a couple different ways I can do this. One is I can get Minikube's IP address, Minikube IP, and that's this. Minikube assigns itself an IP address whenever you create a new cluster, and then it removes it when you're finished with the cluster. And I could just take this IP address, tack on the port, and get it in my web browser. But Minikube also does something else, and I'm going to open up a browser window really quick. It's on my other screen, so let me bring it over here. So I'm going to open up this browser window, and like I said, I could just paste in that IP address and that port number. But Minikube also conveniently lets you just say Minikube service hello Kate's, and that will do all the work of finding the IP address, finding the port, tacking them together, and launching them in your web browser. So if I do that, it's going to open up a page in here, and you can see that well before YouTube started having music videos be the most popular thing on YouTube, there were fun videos like this, which if you haven't seen it, go look up Charlie Bit My Finger. Anyways, so that is our little application. It's just a web page. It's not a very special application. We're going to build a special application soon that we can deploy into our cluster that does a lot more than this. But that is that. And then once you're finished with your cluster, you can either turn it off for now and turn it back on later with Minikube halt. Or in my case, I'm finished with this. I don't really need it anymore. So I'm going to say Minikube delete. And that's going to delete the cluster for me. And that's all I want to show for building a little cluster and running things locally. The point of this is it's not hard at all. And I'm running a live stream on this computer right now. It's using a lot of bandwidth. It's using a lot of CPU. And it can still run this thing. Originally, I wouldn't say a long time ago because it's only been like 5 or 6 years. Originally, it was very hard to get Kubernetes running locally and do testing in it and have quick test cycles and things like that. But as time has gone on, it's gotten a lot easier and a lot quicker. And the point of this is it's very easy to bring up a local cluster for testing. And throughout this series, I'm going to show you ways that you can make sure you don't shoot yourself in the foot when you test things locally versus in a production cluster. And we'll get into that in episode 3, 4, 5 probably. So anyway, another thing that a lot of people want to know is where can I go to get help? Again, my window's in the wrong place. There is tons of great documentation. Kubernetes docs. Kubernetes has some of the best open source documentation I've encountered. For example, this Minikube example that I have here, a similar example is in the Minikube 101 Hello Minikube example. And there's so many great tutorials here. Even if you stopped watching this series after this episode and never looked at another episode, you can learn so much from these docs. And just like with Ansible 101, I'm going to give some examples. I'm going to show you how things work, but the documentation is where I usually go when I'm having a question or when I'm having an issue. In addition to that, there's a Kubernetes Slack that is a great place to ask questions when you're having problems. I don't remember exactly how to get to that, but you can just search for Kubernetes Slack. And something amazing with the timing. So I actually chose today's date a couple months ago I was waffling on when exactly to start, but today's date worked out for my schedule really well. And today is also the first day of KubeCon Virtual. And you can actually, I guess yesterday was the first day, but today there's the first keynote. I don't anyway, KubeCon is going on this week, and it's great timing. And you can still register for it. I think it's free to register for just the keynotes, but you can also register for the entire conference and watch sessions. But unlike KubeCon, all of this content that I'll be doing in the series is perfectly free. So, hopefully some of that KubeCon content will come out on YouTube and other places later, so you can learn about that. But one of the disadvantages, I think, of conferences like KubeCon is sometimes they're more vendor heavy. So it can be hard to separate the wheat from the chaff in terms of what is something that's going to teach you something versus what is something that's just going to sell you something from a vendor. But there are some vendors that are really awesome. And like I said earlier, I think Amazy.io, who is the sponsor for the series, is one of those vendors who actually does things the right way, and they're trying to help you. So again, please check them out. This is all I have for today. Usually these episodes will go for a full hour. This episode, I'm going to cut it off now, mostly because I wanted to just make sure we got through the basics. But next time, I'm going to cover containers and Docker in particular. Docker is not the only way to do containers, but I'm going to cover the basics of containers because I know a lot of people, even if you use containers, even if you use tools on your computer that manage containers and things, you might not understand how to build a container, how to manage it, where to put them, and how to deploy them and things. So I'm going to talk a lot about containers in the next episode, and we're going to build a custom Go app. Now, this is Kubernetes 101. It's not Go 101. So you're not going to go from not ever seeing Go to being like a Go professional that can get a job somewhere. But you'll at least know how to set up a Go app and compile it. So we're going to do those two things in the next episode. Please go ahead and subscribe to my channel if you want to keep seeing these. Thank you, everybody in the live chat. Another thing that we're going to start doing in the future episodes is going through some of the questions and things and discussion that ends up in the live chat. It's hard for me to keep up with it during the stream, but after the stream, I usually go through it. And so if you have anything that you want to discuss, I will try to get to those things in future episodes. But please also check out cube101.jeffgeerling.com. This is where I don't have it posted yet. My goal is to have it posted by today, but I'm going to have a schedule of all the episodes up here soon so that you can see what future episodes will have in them. But I'm posting each episode to the site as they occur as well. So anyway, thank you very much. Click subscribe. I will see you next time.